Good morning, good afternoon, good evening, everybody. Welcome back to day 3 of the OWSD 6th General Assembly and International Conference. We've had 2 wonderful days so far. I'd just like to tell you that we've had 1,540 registrations for this conference so far. People coming from 92 countries and even more in terms of residents, people living in 103 different countries. And on Monday, we had 1,600 viewers. And yesterday, which was just a smaller panel session, we had 450 viewers. So this is really fantastic to know that we've got such a big and such a diverse audience coming from all over the world. I'm sure for this session, which is, we have an internationally renowned speaker coming up very soon. We'll have even more viewers. So just to let you all know that we're in fantastic company. Today's theme is the importance of basic sciences for development. And we are extremely privileged to have Fabiola Gianotti, who's the director of CERN, who'll be talking to us in 1 hour's time from now. She has wanted to come in and give a 1 hour and be here for 1 hour live with us. So we are really privileged in her very busy schedule, and she's also traveling today, so she's taking time out to do this in between countries and in between tasks. But before we listen to Fabiola, we have 4 wonderful members of our panel, all inspiring scientists working in the basic sciences who are going to reflect on the topic before Dr. Gianotti speaks. We hope the discussion will provide interesting material to take forward into next year, which is the International Year of Basic Sciences for Sustainable Development. So the organization of today's sessions are that we will have a 1 hour panel, and then we will have a 1 hour session with Dr. Gianotti presenting, and she will then be interviewed by Philippines physicist Raina Bell, who is going to ask her some questions, and then we'll return back to our panel and we'll have opportunities for questions from the audience, finishing up around 4:30 this afternoon. So very busy afternoon ahead. And now I'm going to introduce you to our panel moderator. I'm really happy to introduce Shobhana Narasimhan, who is based in India and is professor in the Theoretical Sciences Unit of the Jawaharlal Nehru Center for Advanced Scientific Research in Bangalore. Shobhana's research is in computational nanoscience, which I hope she has the opportunity to tell us something about also a bit later on. She has an active interest in reducing the gender gap in science. And I know this personally because Shobhana has been a fantastic trainer and facilitator working on career development workshops for women in physics. And she's done special training sessions for our early career fellows. And she also was invited, I think, by the OWSD Rwanda National Chapter to give a wonderful science communications and training session there, which she might have time to tell you about too. She's been a member of the Working Group on Women in Physics of IUPAP and the Task Force on Women in Science, as well as the Standing Committee on Women in Science of the Government of India. She's published papers related to the causes and patterns of the gender gap in STEM fields, and she's a fellow of the Indian Academy of Sciences, the National Academy of Sciences of India, and the American Academy of Arts and Sciences. And as well as collaborating with OWSD, Shobhana has been running these career development workshops with the International Center for Theoretical Physics, which is the campus where the OWSD Secretariat is based. So, Shobhana, we are so pleased. Thank you so much for accepting our invitation to chair this very prestigious and important session. And over to you.
Thank you, Tanya. I'm very happy to be here, very happy to moderate this session. A reminder that, as Tanya said, later today we'll be hearing from Fabiola Gianotti, the director of CERN. But before that, we're going to have this panel discussion with 4 wonderful speakers. A reminder to all of you that if you have questions, please post them in the chat box and we will take them up either directly after the panelists have spoken or later after Dr. Gianotti speaks. So let me go ahead and introduce our 4 speakers who are going to talk to us and discuss the importance of basic science for development. So our first panelist is Marian Nkansah. She's an associate professor in chemistry at Kwame Nkrumah University of Science and Technology in Ghana. Welcome, Marian. Marian was also the winner in 2021 of the OWSD-Elsevier Foundation Early Career Award. Congratulations for that. Our second panelist is Maryse Nkoua Ngavouka. She's a lecturer in physics at the University Marian Ngouabi in Congo-Brazzaville. Is Maryse here? Maryse was awarded a very prestigious OWSD Early Career Fellowship in 2018 and is one of the first ever graduates from the program. I think she is teaching and she may not yet have finished her class, but she will be here very soon. The next panelist we have is Hanna Rodriguez Hertz, who's from Argentina. She spent much of her academic career in Uruguay, and she's now a full professor of mathematics at the Southern University of Science and Technology in China. Hanna was vice president for Latin America and the Caribbean of the OWSD Executive Board from 2016 until very, very recently, I think maybe till yesterday, when the official handover from the old board to the new one was done. And finally, we have Kate Shaw, who's an experimental particle physicist from the UK. She's based at the ICTP in Trieste, Italy, as well as working on the ATLAS experiment at CERN. Kate founded and coordinates the ICTP Physics Without Frontiers program. Each panelist has 5 minutes to say their first thoughts on the panel theme, which I'll remind you is looking towards 2022, the International Year of Basic Sciences for Sustainable Development. Kate needs to be brought onto the stage. Yeah, there she is. Okay, so let's hear first from Hanna. Hanna, can you tell us in 5 minutes your thoughts about basic sciences and their importance, and about, especially in the context of next year being named the International Year of Basic Sciences for Sustainable Development. Over to you, Hanna.
Thank you. I'm very honored to be invited here. And of course, I think there's much consensus on whether science is essential to development. But when it comes to basic science, there's not such a clear consensus on that. And I suffer that, especially being a mathematician from a developing country. Usually I am being questioned about how do you apply your knowledge? I mean, my knowledge is pure mathematics. I'm in basic science and I have no direct application. I am not in applied sciences. And so I think science is an ecosystem, and it is not about divided compartments. So every part of science is essential, and so is basic science. It is very hard to convince funding institutions to emphasize the importance of basic science. We develop theories, and what we do are models, and what we do is essential. And especially for developing countries, it is essential what we do. We are some people have the model that we should only do applied science and just consume what developed countries do. And I strongly disagree with that. I think it is essential for our independence that we have our own basic science. Having basic science is essential in developing as ecosystems. It is indispensable. We need to do that. And I have the issue. I have to convince my own funding institutions of that. But I hope that this is more and more something that we understand, that it is essential that we develop our basic science. It is impossible to be a developed country without having our own basic and fundamental research. Fundamental research does not have to have any immediate application. It is about developing theory. It is about thinking ourselves. I mean, just wanting to be curious about what we want to be curious about. It is essential. I mean, Google or many super important structures today wouldn't be possible without basic science, without fundamental research. It is essential that we can be free of thinking what we want to think and not be tied to what is has an immediate application. And this is all I want to say for now. Thank you so much.
Okay, thank you, Hannah. I'm happy to say that Maryse is now with us. Welcome, Maryse. Can you tell us in about 5 minutes what you think about this topic, about the importance of basic sciences and its importance, especially for developing countries, and especially in the context that next year will be the International Year of Basic Sciences for Sustainable Development. Maryse, I think there's some background sound. Okay, that's gone now. Yeah, please go ahead.
Okay. Yeah, I strongly believe that basic science. Hello?
Yes, go ahead.
Hello. Oh, okay, thank you. Yeah, thank you for giving me this opportunity. I strongly believe that basic science, it's one of the important things, especially in Africa, because we use most of our country do not have like high applied laboratory. We mostly base everything linked to science on theory. So it's like a must for it. It's like the basic of everything we are doing. It's mostly based on theory. So if you would like to proceed on anything related to theory, so it's your mind who is thinking first. So for us in Africa, we mostly do theory and we mostly do basic consistent applied science. So this is what I think about the basic science, mostly in Congo.
Are you done, Maryse, or do you want to say anything more?
Yeah. No, I'm done. Yeah, thank you.
Okay, thank you so much. Just to remind you that Maryse is from Brazzaville, Congo. Now, can we hear from Kate Shaw? Remind you again that Kate Shaw is at two places. She's at ICTP and she's also at CERN. Are you also at the University of Sussex?
Yes, at the University of Sussex.
That's what I seem to remember. Yes. So, Kate, let's hear from you.
Hi, thank you so much, Shobhana. Yeah, so I wanted to talk a little bit about the topic for today, the basic sciences for sustainable development. So I work on the Atlas experiment at CERN. Of course, that's a basic science laboratory, and at the International Centre of Theoretical Physics in Trieste, which is a fantastic place to work, because not only are they at the cutting edge of fundamental sciences, we do physics and mathematics, but they also have a dual mandate to support fostering physics and mathematics in developing countries. So I think we're going to hear much about why basic science is actually crucial, almost a backbone really towards sustainable development. So I just want to highlight a little bit about how it must go hand in hand with open science and open access, and then talk a little bit about some of the issues that we see. So basic sciences, when it's hand in hand with open science and open access, it means that scientists from different places around the world can access all the recent developments and data and software and educational materials that are created by centres of fundamental science. For example, at CERN, we have open data, complete mandate. That means that the data that we create, we share around the world, and we also try to get out our software and computing and programming skills all over the world, so that students and scientists all have access. So I think having this open access and open science along as a keystone in the basic sciences allows us to help bridge this gap you see between developing and developed and less developed countries. We also need to see it connected to societal needs. So as we know, in various different places, local societal needs are completely different. And so scientists all over the world need to have access to not just scientific data, but also need to have access to resources. We work in a lot of places where scientists simply are in a country where their government doesn't put any funding or any resources into the basic scientists. And so how can they adjust to not only be able to do their fundamental research, but to support people in more applied fields to address local issues? Or of course, global issues have the same issue. If we're trying to address something globally as a scientific community and as all citizens of the world, everybody needs to have access to understanding basic science. So the education and the trickling down of information and that growth in scientific capacity around the world is a real absolute star of the show of investing into basic science. So with our program, Physics Without Frontiers with ICTP, it's really about we work with all developing countries to do training, basically through our volunteer network of scientists who are from these countries themselves, to do training and run projects for students and for faculty in countries all over the world. But we also have a focus on less developed countries and in fact conflict nations, where maybe people don't have access to scientists doing leading research. And again, this is why you need to have this open access availability. So in some countries that we work with, I mean, for example, in Afghanistan, where we've been working several years now, they didn't have, due to years of complex, access to an MSc program. And so in order to develop, they need to be able to climb the steps of attaining, academic credibility. And in many different countries that we work, there aren't opportunities, there's not resources, and there's not funding. And so that's what I really see as something to grab hold of in going towards looking at the importance of basic science is also to make sure that we support students, incredibly bright students that want to go on to do research and have bright ideas, but they have no stepping stone. They're not able to get a master's, or the faculty maybe aren't able to get a master's or a PhD opportunity. So that's what we hear from our volunteer network and from people around the world, that even today, with all this investment, there still is not enough opportunity or funding to be able to do basic research in many countries and to be able to go on to masters and PhD. So we've been actually partnering with several universities to provide scholarships for students from universities without masters to be able to go and study their masters elsewhere. And that's been a really successful program we'd like to do elsewhere. And I know that OWSD, ICTP, TWAS, CERN, all do fantastic programs. And I think this is something that needs to be commended, especially when we highlight next year this kind of this topic and need to support much more through government funding.
Okay, thank you, Kate. We'll come back to you later. I think, can we hear now from Marian? A reminder again that Marian is at Kwame Nkrumah University in Ghana. And also a reminder to everyone in the audience that if you have questions for the panelists, please write them in the chat box. Thank you. Marian, over to you. You're muted, Marian. Yeah, please go ahead and share your screen. Yeah.
All right. Thank you, Shobhana. I thank you for this opportunity. Permit me to start with these acknowledgements and also to talk about some of my engagements, because that came with the invitation to be part of this panel. Thanks to OWSD-Elsevier for my selection for this year's award, the prize, and the exposure that has offered me and my work. And also to share with members that I'm a member of the Global Young Academy and once an executive member, and this association is for younger scientists that gives them a voice. And it's the target or the requirement is that you're doing good science, whether it's basic or applied. And I'm also involved in the Ghana Young Academy, the National Science Forum, the AAS Affiliates Program, and the TIAN Program. And these are all platforms for younger scientists, whether applied or basic, whether humanities even, to have a space to showcase what they have and also to learn from each other. Now I move to the subject matter for our discussion, which is basic science. I want to provoke us a bit by saying that I think these two terminologies, as in basic science and applied science, have been used for administrative convenience. And I say this because generally basic science is defined as work that helps to add to existing knowledge or is knowledge-driven or curiosity-driven, whilst applied science creates practical solutions to problems or is solution-driven. And that is why funders have adopted these convenience, and it has worked over the years. But the conversation I wish to provoke this today is that I want to believe that every research solves a problem, though the solution might not be tangible in the case of so-called basic research. That is how come when the proposal is being developed, every time there's a portion that says problem statement. So every research solves a problem, that it's filling a knowledge gap or a solution, a practical solution to a problem. So my question is, can filling a knowledge gap be considered a good solution enough? And then to what I do as an environmental chemist and relating that to basic science or basic research, I predominantly look at environmental heavy metals and these areas due to human activities and artisanal activities, e-waste dumping from dust, groundwater, food, and other matrices, and also aromatic hydrocarbons. And my work sheds light on the health effects and the potential risk of exposure to these contaminants in the various spheres of the environment that they present to themselves. And the knowledge generated contributes to SDGs 3 and 6. That is good health and well-being. Information about risk and exposure informs the populace and policymakers in the right decisions and choices to make in order to ensure good health and well-being, and also contributes to SDG 6, which is water quality and sanitation. Now, in conclusion of this session, I'd like to say that basic science holds the key to application. Like any building, basic science is the foundation on which the application rests. And human development cannot be sustainable without basic science. That is, the successes of applied research, the successes of applied science cannot remain and will not thrive without the continued fueling of understanding with new knowledge from basic science. Therefore, there is a need for a deliberate effort by policymakers and funders to always commit a percentage of funding to basic science, because the beginnings of scientific breakthroughs are not always fancy or tangible. And so this will be my opening remarks for this session. Thank you for your attention.
Thank you, Marian. I think you raised a very interesting point there about whether one can really make this distinction between basic science and applied science. And I think it would be nice if we can discuss that a little more. But before we get to that, there's a question for Hannah from the comments. It's from Dina Machuwe, who I gather is an OWSD Earlier Career Fellow from Tanzania. And I'm told that there's a film about her that's been made by OWSD and which you can see on the OWSD website. The question says, thank you, Hannah, for the good background on mathematics. What is your experience in bridging theory and practice in the field of mathematics?
Thank you. Well, actually, I'm in pure mathematics. I don't do practice. I do pure mathematics. It's just theory on my side. That is what I try to explain. This is what basic science is all about. Applied science do applications. We do just theoretical models. We don't do practice. I mean, that is what we do. What we do might or might not be applied in the future. We don't know. For instance, what Google used to do their all what they do was established 1 or 2 centuries ago. When they did that, nobody knew that in the future that was going to be applied. But if you had to do that now, you wouldn't be able to develop such machinery in mathematics. That is what theory is all about. We don't do practice. I mean, we don't do applications. We do basic science.
So, Hannah, would you say that the distinction, however, between pure mathematics and applied mathematics is sort of an artificial one because you decide whether it's going to be very soon useful or useful at some point far in the future?
We don't know. I mean,
I'm asking, is that the difference between pure mathematics, basic science mathematics, and applied science mathematics?
We don't know. There is no clear division. There are, as I said, there are no compartments in science. For instance, when all number theory was developed, was like game, was like a playing of mathematicians. We were playing with numbers. And now, years later, all the cryptography was a huge application of this number theory. And now, everything that has to do with cryptography has to do with national security, with crypto coins and whatever. And when it was first developed, nobody knew about that further development. Right. So you don't know.
So you're saying when you do basic science, you don't know when it's going to be useful.
And you don't know whether you don't know when, and you don't know whether it's going to be useful. Okay. You just do it because of out of curiosity, and some of it is going to be super powerfully useful, and some of it won't be useful at all. You don't know.
Okay, so I would like, there's a question for Maryse. It says, thank you, Maryse, for the very interesting remarks. My question is, what kind of models are you applying for the risk assessment from heavy metals or other environmental pollutants for the electricity grid in Congo, I guess? And I think the question is from Sablework McNonan Shigan.
Okay. Thank you for the question. Actually, we are using like hybrid system coming from 2 kinds of bio resources. So we are using solar panel combining with biomass. But those biomass we produce. So we produce the bio-oil through some thermochemical reaction. So it's not like we are working with pollutants. No, we are just using the biomass and proceeding with some thermochemical processes. Then as soon as we have the bio-oil, we combine it with your generator and combine the second system of solar panel and produce electricity. So the idea I got funded because I need to have a little of a recap of the story. So I'm a physicist for sure, and then I graduate my PhD in nanoscience and nanotechnology. But as soon as I decided to come back home, I was, of course, as I say at the beginning, back home, we are doing most of the basic science. So we don't do applied science. So with all of my nanoscience, so I wanted to do something which will be directly applied to the community. And then I'll start to think of what is the problem people were having in the community. And the basic problem was electricity for sure. And then so I said, okay, since I left a little bit of theory, now I'm in the applied science. I will work with people of basic science. What are they doing in basic science in order to produce this electricity? So I combine a team of engineers, biologists, even chemistry, in order to have this system coming from two sources, so solar panel and the bio oil. But the bio oil we produced at the beginning was not that a good quality, because we didn't have a good bio oil. So this is when I said, okay, I'm a nanotechnologue, so I will produce something called nanoparticle, which will be mixed with this bio oil in order to have a cleaner and more efficient bio oil. So just to say short, I use all the knowledge of basic science. I use my applied knowledge of nanotechnology in order to produce an efficient bio-oil back home. And the really good point about this bio-oil is that we are using, we have in Congo, we have problem of algal bloom. So we use the same algal bloom coming from Congo River, and then we transform it in order to produce those bio-oil. So it was a project. People will say, but you are a physicist, how are you ending to bioenergy field? But because I have all this knowledge of basic science, and I moved toward applied energy, and I was able to have this project on end, let's say. So now the material, in order to come back to the question about the material I'm using, it's some biosynthesized nanoparticle coming from simply algae, and combining with some zinc oxide product. And those nanoparticles, this is what are we using to have an efficient bio-oil, because it's like purified the bio-oil we are producing. And this, yeah.
No, go ahead. If I thought you were done.
It's okay.
Okay, I mean, what you said led me to another very interesting question, which I would like maybe all the panelists to talk about. So maybe we can bring them all on stage. I'd be interested to know what everybody thinks about this. I think this is basically at the heart of this session, which is, do you think that scientists in developing and developed countries should prioritize different kinds of science? Should they be doing different meanings? I think this is so. So, if you are in a developing country, should you place a greater emphasis on applied science? That is what some people often say, or that seems to be not what all of you think, but let's discuss that in a little more detail. Or do you instead think that maybe you should do more basic science in developing countries, or does it not matter at all whether you're in a developing country or a developed country? So I don't know who would like to go first. Maybe Marian?
Yes, so in science is science. So I would propose that each jurisdiction should do a combination of both basic and applied. Because if developed countries, developing or least developed countries rely only on information from elsewhere with the attempt of doing applied science, sometimes there are gaps in the application. So it's very necessary that all jurisdictions are involved and are part of the knowledge generation. And then when it comes to the application, then specific jurisdictions can focus on what solves their peculiar problems.
Okay, and what do you think, Kate?
Yeah, I absolutely agree with Marianne. You need to be able to do both applied and basic science in every country. And basic science, I mean, it's not just the fact that it means that you have local experts that can support, developing science for societal needs. But basic science in universities allows that research and that understanding to trickle down, so that your students, the university, then become very well educated by working with researchers in the field, and it improves the scientific education and scientific capacity of the country as a whole. So it's super important to have in every country that kind of interplay between basic and applied science. And of course, applied science will always benefit from that interaction. I mean, that's what we have all the conferences and exchanges between these kind of fields for. But having applied science and working with basic scientists, they really allow that interplay to have new and innovative new ideas to solve issues.
Thank you, Kate. And Hannah, what is your opinion? I mean, you are doing basic science and you said it's very pure mathematics. So what do you feel?
Well, my feeling is that the establishment says that basic science is a luxury for developed countries. But actually, if the developing countries do not do basic science, they are condemned forever to do to be just technicians. And that might not be the best thing. I mean, there are specific issues that we have as countries that require us to develop our own theories. And you cannot develop your own theories if you do not your own basic research, your own fundamental research. That is what my opinion is.
Maurice, I would be interested to know what you think, because you especially mentioned that when you returned to your country, you decided you wanted to work on something more applied that sort of answered the needs that you saw around you. So is that just a personal choice, or do you think this should be a national priority? What do you think?
No, I think I strongly believe it should be equally used, basic and applied. And for my choice, it's also because most of my colleagues were already working on the field on this topic, but from theory point of view. So people have this database of information on everything related to every process, but from theory, from basic science, so they have it. So it was just for me, it was easier for me than to apply to apply this project, because people were doing it from theory, but they were not able to implement it. So, and I always think that it's important to have a country having strong basic science, because it's like a database. So as Jana just say, because you have all this information, sure, people will say, but where are you using it? It's just theory. But if you want to develop your country, you need those information in order to be able to apply this specifically for your country. So I think it's equally important for all the fields. So, and now, for example, in my department, when I decided to do this project, people are more now interested to say, okay, I did X project on this basic theory. Maybe we could try to apply it to see if it will work or not. Like I'm saying, visually, physically, let's say. So it's very, very equally important to use both of the approach.
And regardless of whether you are in a developed country or a developing country, you would say.
Yes, I believe. I strongly believe, yeah.
So there seems to be unanimity on this point in the panel, I think. There's a comment from Bella. She says, start with the basics for students to understand research, then venture into applied science. We just have some 3 minutes before we take a break. So any comments any of the panelists want to make before we go to the break? Marian, you want to say something?
Yeah, I would like to say that it's very, very important that next year has been dedicated to the basic sciences for this discussion to be given a global platform. And so it's going to be very useful to both practitioners of science and those who have the money to support science. At one table or on one platform, discussing the importance of what I call the fuel that every research runs on, and without which we cannot really have sustainable development.
So do you think it's important to have this be announced as the Year of Basic Science for Sustainable Development? Because many people don't realize that you need basic science for sustainable development. Do you think the general public really thinks you only need applied science for sustainable development?
Yes, it's possible that there hasn't been that consciousness. It's been overlooked. But once it's given the limelight, is brought to the table and given the focal point, then discussions will be evolve around it. And that public conversation will create the awareness, even for those who probably might be aware, but have not paid much attention to the importance of basic science.
Okay, one very last quick question. I mean, all five of you agreed on this point basically, but do you think there is any disagreement within the scientific community about this? Is this debated?
Can I continue? Yeah. I think within the scientific community, there is mutual respect for all the sciences, but probably it's the divide comes when it comes to where do fund managers put their money to. And generally, I believe globally, there's this movement of innovation, entrepreneurship, and that kinds of sheds cast a shadow on basic science, which in most cases, the outcome doesn't have any immediate application or might not be fancy or tangible as applied science will look or present itself. So among scientists, I want to believe there's that understanding that they are equally important, but it's those out there who want to have their money's worth, so to speak, and policymakers who also want to convince their partners that this is equally important, though the returns might not be immediate.
Mm-hmm. So, I mean, in India, where I'm from, there's interesting change I see happening, because when I was a student, I think basic science was respected more, and they sort of looked down on people who did applied science. I don't know if this is some reflection of the caste system in India or something like that. I'm serious, but now I see there's much more value given to applied science, especially by funding agencies, etc. We have one last question we can take before we go to the break. It's from Shalini Abesinghe, and it says, can't we have an accelerating process to implement either basic or applied science knowledge for the betterment of the world? Although we have thousands of research publications on site, the implementation is lacking. So I guess she's talking about, the knowledge is produced, but then it is not necessarily converted to a useful application very rapidly. Sometimes there is a big gap there. So do you have any thoughts about that? Kate?
Yes. Yeah, I think it's an important point, and it comes down to what I was saying a little bit in my introduction about having this kind of open access to science. Now, I'm not saying that would solve the issue completely, but I think it needs to be more easy for people outside of either the scientific community or outside of our specific fields to be able to access data and resources, and also to be able to quickly apply for funding if they do feel that they have an idea that they would like to use some scientific funding for a societal need. So I think that's a really good point. And I think governments can think of how to implement ways that make this process more streamlined and also provide access to quick resources of funding, along with supporting the open science infrastructure.
Okay, we have another comment from Dina. She says, well said, Marian. Returns may not be immediate, but we need to continue investing in basic science to obtain theories that will eventually be used by applied scientists. All applied science comes from theories. Hannah, that sort of repeats what you were saying about mathematics. Do you have anything you want to say quickly before we go to the break?
No, I really coincide with all my fellow panelists here. I think that basic science and applied science are complementary, and there is no clear boundary between them. So all sciences are science. That's what I want to stress is that developing countries also should develop basic science. It's not something that is only a luxury from most advanced countries. That's all.
Okay, so there's a comment from Grace Jucharan. She says, maybe we're at a point when we should consider whether the use of pure and theoretical to describe what we consider as basic science is useful. So I think that's a very interesting point, because words like pure are sort of value judgments also, and maybe we shouldn't be using those. So especially I'd be interested to hear what Hannah has to say about that, because it's used a lot in mathematics. You say pure mathematics and applied mathematics. Do you think we should use it instead a different adjective than pure?
I don't know.
Okay,
I
so
don't
think
know.
about it over the break. So I think we can all take a quick coffee break now, and we'll come back in maybe 10 minutes. And then we will have Fabiola Gianotti speak to us. And of course, do remember that our panelists will continue to be with us. And after Dr. Gianotti speaks and after the Q&A session with her, we will have one more Q&A session with these panelists. And so we can continue this very interesting discussion. Thank you, everybody. Hello, everybody. Welcome back. I hope you had time for a quick coffee or a juice or something. So we are very happy to welcome Fabiola Gianotti to our conference. Welcome, Dr. Gianotti. I will briefly introduce her. Fabiola Gianotti is the Director General of CERN, the European Laboratory for Particle Physics. She is incidentally the first woman to hold this position. She received a PhD in experimental particle physics from the University of Milan in 1989. Since 1994, she has been a research physicist at CERN, and since 2013, she's also been an honorary professor at the University of Edinburgh. Let me tell you about her research work. Dr. Gianotti has worked on several CERN experiments covering detector R&D and construction, software development, and data analysis. From March 2009 to February 2013, she held the elected position of project leader called spokesperson of the ATLAS experiment. And very famously, on 4th July 2012, she presented the ATLAS results on the search for the elusive particle called the Higgs boson in a seminar at CERN that saw the formal announcement of the discovery of this special particle by the ATLAS and CMS experiments. This was widely covered in the media. Dr. Gianotti is a member of several international committees and has received 14 honorary doctorates from universities around the world. She is an associate member of several academies, including the Italian Academy of Sciences, the National Academy of Sciences of the USA, the French Academy of Sciences, the Royal Society London, the Russian Academy of Sciences, and the Pontifical Academy of Sciences. She was awarded the honor of Cavaliere di Gran Croce dell'Ordine al Merito della Repubblica Italiana. I may not have pronounced that right, if so, I apologize. She received the Special Breakthrough Prize in Fundamental Physics, the Enrico Fermi Prize of the Italian Physical Society, and the Tate Medal of the American Institute of Physics for International Leadership. She was included among the Guardian newspaper's top 100 most inspirational women in 2011, and she ranked 5th in Time Magazine's Personality of the Year in 2012. Welcome, Dr. Gianotti, again, and we look forward to hearing from you. You're going to talk to us about scientific research, a key asset for the future of society.
Thank you very much. I hope you can see my slides and
yes,
you can hear me well. Thank you very much for the nice introduction, and also many thanks for the invitation to talk at this very interesting and important conference. So I'm going to talk about the importance of scientific research for the future of society and for a sustainable world. And I will take the example of CERN, where I work, and then, of course, I will draw some more general conclusions. So let me start by saying a few words about CERN, and emphasis, of course, will be on the main topics of this conference and the main values of this conference, so women, science, and development. So CERN is the largest particle physics laboratory in the world. It is an intergovernmental organization based in Geneva, and our mission has 4 main pillars. The first one is science. We do research in particle physics, and particle physics is the most fundamental of all sciences because it studies the elementary constituents of matter and of the universe. Elementary means the constituents that cannot be cut into smaller pieces. And this research has been awarded over the decades by several discoveries. The last one is the Higgs boson in 2012, which was mentioned before, and Nobel Prizes awarded to scientists working at CERN. Now, the second component of our research work is related to technology and innovation, because our scientific goals are extremely ambitious, and therefore they require very complex and advanced instruments in the fields of particle accelerators, particle detectors, and computing infrastructure, and the development of advanced technologies, cutting-edge technologies in various fields that go from superconducting magnets and materials to fast electronics, from big data to vacuum technologies, cryogenics, etc. And these technologies are transferred to society to the benefit of everyday life. The most famous example is the World Wide Web, which was developed at CERN in 1989 by Tim Berners-Lee, who at the time was a CERN employee, and was made available free of charge in 1991 for everyone to use and develop. But there are other examples, for instance, application in the medical field, and I will come back to this later on. The third important pillar of our mission is training, so training of tomorrow's scientists and education, targeting the general public, in particular school students. And last but not least, CERN is a concrete example of collaboration across borders, because it attracts some 17,000 scientists from all over the world. More than 110 nationalities are represented. Maybe I think it's useful to see a little bit about the history of CERN and the motivation for this, I would say, pretty unique organization. CERN was founded in 1954. This was just after the World War II. So the world was emerging from a big crisis. And there were two clear goals in the mind of the visionary founding scientists and founding politicians. The first one was to bring back scientific excellence to Europe. During the war, many scientists had emigrated to other continents. And so we can see in these visionary people the awareness that the economic recovery of the continent also requires investment in science and also goes through fundamental research. And second goal was to foster peaceful collaboration among European countries. And so the awareness already at that time that science can be a kind of glue that brings people together and that science can break walls. If you look at the CERN founding convention, which is a very synthetic and really visionary document, you can read the following elements. First of all, that the organization, the laboratory, should pursue scientific research of fundamental character, so basic research, with no military purpose. Second, that results and information and all we develop should be disseminated and made available to everybody free of charge. So this is what we call today open science. At the time, it was not called like that, but the principle of open science was already there in CERN founding convention, and the organization has been following this principle and values ever since. Then promote international cooperation, so what we call science for peace and training and education. Today, CERN has 23 member states and other associations with other countries with different kind of affiliations. Most importantly, I think we have something like 50 international cooperation agreements with many countries, and most of these countries are actually developing countries. So, and for these countries, signing agreements or engaging into collaboration with CERN and other research organizations is part of their efforts toward development. And for us also, working with them and helping them to bridge the gap with the more developed countries is, of course, an important mission. So capacity building is part of our missions for in the relation with these countries. We have a budget, annual budget of about 1.2 billion Swiss francs per year. Using more friendly units, I used to say that this corresponds on average to 1 cappuccino per year per European citizen. And I would like to stress that the budget stability over decades and international cooperation have allowed CERN to accomplish extremely ambitious and complex objectives and goals and projects that no country could afford alone. And I will give you examples later on. So stability in the funding for research and cooperation across borders have been fundamental. So a few words about scientific mission. I will try to be very simple. So what we do is to study the elementary particles, among which we find the building blocks of matter and of the universe. So you all know that matter is made of atoms. Atoms are made of a central nucleus surrounded by a cloud of electrons. Nuclei are made of protons and neutrons, and protons and neutrons are in turn made of smaller particles called the quarks. And as far as we know today, electrons and quarks are elementary particles that cannot be cut into smaller pieces, and they are the fundamental constituents of all the matter we know. So the matter we are made of, the matter that we see around us on our Earth, the matter of the visible universe. And particle physics at modern accelerators, and CERN runs the most powerful accelerator ever realized, implemented by humanity, allows us to study the laws of nature at the level of the quarks or below. So on physical scales, corresponding to a billion of a meter. So this accelerator can be seen as giant microscope that allows us to study the fundamental constituent of matter. And the smaller are the structure you want to study, the more energy you need. And so for studying human cells, a tabletop microscope is enough. But if you want to study the elementary constituents of matters, the quarks at the level of a billions of a meter, you need big accelerators and a lot of energy. At the same time, these studies of the very, very small allows us to understand the very, very big, so the structure and evolution of the universe. And this is because we know today that the universe had origin some 14 billion years ago from a big explosion called the Big Bang. At the beginning, the universe was extremely dense and extremely hot, and was essentially gas of elementary particles in their free state. So that's why by studying the elementary particles and their interactions, we can understand how the universe behaved in the early epochs of its life. Then with time, as a result of this explosion, the universe expanded and cooled down, and with time, the elementary particles started to get together to form first the quarks to form neutrons and protons, then neutrons and protons to form nuclei with electrons to form elements, chemical elements, atoms of the lightest elements, so hydrogen, helium, etc., and then so on and so forth to form the macrostructure that we see today, so galaxies, stars, planets, etc. And there are two ways to study the structure and the evolution of the universe. The first one is to use telescopes on Earth or in space, and telescopes looks at the big objects, so galaxies, stars, etc. And by looking at the farthest object, they go back in time. But if you want to go back really very close to the origins, to the Big Bang, then the only way is to use accelerators, which today allow us to go back to something like 10 to the minus 12 seconds from the Big Bang. So millions of a second from the Big Bang. So the most powerful accelerator ever is the Large Hadron Collider in Geneva. So this nice aerial view of the Geneva region show the Mont Blanc in the background, Lake Léman, the Lake of Geneva here. This dashed white line shows the border between Switzerland on the top of the screen and France on the bottom of the screen. And here you can see this yellow circle, which indicates the position of the Large Hadron Collider. It's a 27-kilometer ring, 100-meter underground, so the surface you don't see much. And we started operation in 2010. So what does it mean, operation? Starting operation means injecting and accelerating two beams of particles, two beams of protons, into two opposite directions of the ring, in accelerating them to the highest possible achievable energies, where the limit only comes from technology, in particular from the superconducting magnets, and then to bring them into collision at 4 points of the ring, where we had installed in 4 big underground caverns, 4 big instruments called particle detectors, called ALICE, Atlas, CMS, and the RHCb. These are really big. Atlas is half the Notre Dame Cathedral in Paris, so you can imagine the size of these big instruments. So the goal of these instruments is to look at the product of the collision. In this high energy collision between the two beams, many particles are produced, and these instruments, these particle detectors, surround the full solid angle around the collision point, and they detect ideally every single particle produced in the collisions. And so this allows us to reconstruct, to have an image of the collision event, and then to understand what happened in this collision. And this allows us to understand how matter behaves at the most fundamental level, at the level of the quarks, but also to look at any massive new particles that are produced in the collision, like the Higgs boson itself. So if the accelerators can be compared to giant microscope, these detectors, particle detectors, can be compared and assimilated to giant digital camera, which take pictures of the collision events. 2 years after beginning of operation in July 2012, Atlas SCMS announced the discovery of a new particle, the Higgs boson, which is a very special one. And this discovery then brought to the Nobel Prize in Physics, which was awarded in 2013 to François Englert and Peter Higgs, the two theorists that they had predicted at the beginning of the 60s the existence of this particle. So why is this particle so important? So I cannot, of course, go into the details of the theory and of the physics, but let me just tell you that I mentioned, as we all know, that we are all made of atoms. And now atoms will not exist as bound state. They will not stick together if the Higgs boson was not there. So this particle is absolutely essential also for our own life. So the LHC required the development of new and unprecedented technologies. For instance, here you can see a spectacular photograph of the underlying tunnel, the 27-kilometer tunnel. You see these blue tubes. These are cryostats that house cutting-edge superconducting magnets, which have allowed the LHC to achieve unprecedented collision energies and therefore also to discover the Higgs boson. These are superconducting magnets, so they work at low temperature. The LHC works at 1.9 Kelvin, which corresponds to minus 271 degrees Celsius, which makes of the LHC one of the coldest places in the universe because, as I mentioned, the universe had origin from a big explosion. At the beginning it was very hot, and then it cooled down, expanded and cooled down, and if you ask yourself what is the temperature of the universe today is 2.7 Kelvin, whereas the LHC works at 1.9 Kelvin. I have here a few impressive numbers to give you an idea of the challenges that we had to meet in order to realize and to implement this extraordinary project, and also of the ingenuity and the technologies that we had to develop and deploy and operate. So, why was the LHC built? The LHC was built to answer some outstanding questions in fundamental physics. I already mentioned the problem related to, well, the importance of the Higgs boson, which is related to the mechanism by which the elementary particles that we know, among which the quarks and the electrons, acquire a mass sometimes in the early universe. And this question is in large part answered. But there are many more, and let me just mention one of them, which of course inspire and guide the future research in particle physics and beyond. One is the dark universe, so I think you are all familiar with it, but just let me remind that when you look at the sky overnight and you see the beautiful star, galaxies, and planets, keep in mind that what you see is only 5% of what is out there. The rest, 95%, is a question mark, meaning that the rest is made of, it means that only 5% of the universe is made of the matter of which we are made of, the matter that we know, atoms, chemical elements, the matter that we find also on our planet. The rest is made of form of energy that we don't know and which do not interact with our instrument, and so for this reason they are called dark energy and dark matter. So understanding the dark universe is one of the obsession of scientists today, or physicists today, not only of particle physicists at accelerators, but also other colleagues in cosmology, astroparticle physics, etc. And there are many other intriguing and fascinating questions I have no time to discuss. As I mentioned before, CERN is also a driver of innovation because our scientific goals require really pushing the technology in several fields and also driving the development in industry. As I mentioned before, because our conventions tells us that whatever we develop should be made available to everyone free of charge for the largest possible disseminations, all of our technologies are transferred to society free of charge. So here you see a few examples. I already mentioned the World Wide Web, but for instance, technologies developed at CERN, accelerator technologies in particular, have allowed society to build new installation and facilities for treating cancer. This is called hadron therapy, and it consists of bombarding the cancer not with the usual X-rays that we get through the usual radiation therapy, but with protons or light ions, like carbon ions. And the advantage of beams of protons and light ions is that they are much more focused and they do not spread all over the places. So for some type of tumor close to absolutely vital organs, or for kids that you want to irradiate with a lot of radiation spreading all over the places, this kind of therapy is recommended. Technologies developed at CERN are used in medical imaging. Dosimetry developed at CERN for radio protection are used in space mission. You can see here one of the CERN dosimeters deployed aboard of the International Space Station, or also used for monitoring the quality of the air for environmental studies, etc. Machine learning and AI, artificial intelligence developed at CERN is used for car automation, and so on and so forth. All of this, the fundamental research and the technologies, will not be possible without the contribution of the 17,000 scientists and engineers, technicians involved in CERN activities. And here you can see a nice map of where these scientists come from. You can see that many of them, a large fraction of the 17,000, come from member states in dark blue, but many also from associate member states, observers from big countries like the US, Canada, China, Russia, Japan, etc. But also several scientists come also from developing countries, from Kenya, from Lebanon, from Madagascar, etc. And in this case, our goals, as I said at the beginning, is to build capacity, to bring the scientists in the circuit of CERN and of frontline research and technology, and so that they can then go back and bring back to their country what they have learned. You can also notice that some of these scientists come from countries that are not the best friend of each other. So we have at CERN scientists from Israel working together with scientists from Iran and from Palestine. So really, CERN is a place where people work together, animated by the same passion for research. If you look at the age distribution of the scientists working at CERN, so these 17,000 people, you see that most of the population is young, because the peak is at 27 years. And above 50% of the population is below 40-45. And at any given time, we train at CERN something like 4,600 young people, including PhD students from various universities worldwide, but also people who enroll for some specific training program at CERN. Only a fraction of them remain in research in particle physics, because some of them want to do something else in their life, or because the jobs in research are not so numerous. So where do those that leave go? 50% of them go to the private sector. So computing, finance, engineering. So you see that our mission is also to prepare them also for a work in the private sector. And the rest go to remain in the public sector, other research organization or other intergovernmental organization. So our mission is to prepare them for their future. So because we have so many young people, educational and training activities are very important. So we have specialized schools for physicists, computing scientists, engineers, technicians. And these schools, since several years now, take place not only in Europe, but also in Latin America and in Africa. We team up with other institutions in our field and beyond. And since 2010, we have been organizing school in Africa, starting with South Africa, then Ghana, Senegal, Rwanda, Namibia. And then, of course, we had COVID and these things stopped, but we are eager to go back as soon as the health situation improves. But also we have a lot of initiatives for non-specialists. So for high school students, every year we host something like 6,000 high school students in our laboratories called School Lab, and we have a very successful high school teacher training program that has been running since the end of the last centuries and has enrolled until now more than 13,000 participants. And a high school student is a multiplier. So if you want to attract, from the young people to STEM, so science, technology, engineering, mathematics, targeting the high school student teachers is also very important, because there are many students, school students, behind a given teacher. We also have a very successful summer student program. It is an undergraduate program that brings to CERN some 300 students every year, of which 150 from the member states and 150, half of them, from non-member states, including from developing countries. And I would like to mention another interesting project and program that builds on CERN openness, collaboration, and collaborative spirit, and open science. So we have teamed up with UNESCO to establish what we call the CERN UNESCO Schools on Digital Libraries. The scope of this program is to improve access to information for African researchers and to increase global visibility of African research. So we run these schools on digital library in different countries. We have been to several of them in Africa, and we deploy an open source digital platform and open source software developed at CERN, so available to everybody free of charge, that is used by the students and by the teachers at this school to learn and to get a system that allows them to improve their access to information and to increase also the visibility of the results of their publication and their research work. A few words about women at CERN. Maybe you can see that at the moment we are in a very lucky situation where we have a president of the CERN Council, which is the body governing the organization, as a woman, Professor Ursula Basler, and the CEO, the Director General of CERN, which is the CEO, myself, also being a woman. So that's very good also to show to the younger generation that there are opportunities. Now, a few numbers about the percentage of women at CERN. You can see here some statistics as a function of time, starting at the beginning of this century, at the end of last century, until essentially today. So you can see here on how the fraction of women at CERN, including all categories from scientists to admin personnel, has been increasing over time. So there has been clear progress, especially when you look at the scientists and engineers. When I joined CERN in 1995 or so, women scientists, we were at the level of 6%. Today, we are at the level of 15%. So there is huge progress, however, still not a satisfactory situation. Maybe it's also interesting to see here the evolution of the fraction of CERN employees in the so-called senior staff, which is the highest level category at CERN. These are the more senior people, which are, of course, which had a very brilliant career. And you see that the fraction of female has been increasing with time, and the fraction of male corresponding has been decreasing, because this is a percentage value, indicating that we pay a lot of attention to the evolution of the career of women, making sure, we monitor the career, making sure that men and women have the same opportunities in terms of career progression, awards, etc. So here are some examples of the CERN initiatives and policies to promote women in science, which I'm sure are common to many other institution. So I will not go through all the details, maybe just pick up a few of them. So we work at different levels. First of all, in increasing the talent pipeline, having enough girls, enough women applying for jobs at CERN. So there we have to play, for instance, on role models, and we disseminate science by sending CERN female science to teach in the local school, but also schools in the member states. And we direct source female candidates through our platform. Then, of course, offering opportunities for new parents in general, not only women, but for also to paternal leave, also to men, by providing flexibility, supporting dual careers. And we also have an on-site nursery and kindergarten. You can see an image here, which houses and which welcomes children from 4 months to 6 years, and so this is very useful for the parents. We have flexible work arrangement like teleworking, part-time work, etc., which has been extended now as a result of COVID. And also we try to build a respectful environment. We have a code of conduct, we have an harassment complaint procedure, we have an ombudsperson, we have a diversity and inclusion program. So What can we learn from this, and what in general, on what can science and scientific research do for society, in particular in the post-COVID era? And so I'm going to conclude with some general remarks. First of all, science brings knowledge. I think I don't need to convince this audience. Science is clearly the fuel of progress, and without new innovative ideas and breakthroughs, sooner or later progress stagnates. And I would like to stress that history shows that often major breakthroughs come from fundamental research. For instance, two great discoveries of the past century, quantum mechanics and general relativity, are absolutely essential for society nowadays. The modern electronics based on transistor will not exist without the knowledge of quantum mechanics, not even the electron microscope, which was very useful to study the virus over the past years. And our GPS will not work if you would not take into account general relativity effects. However, what I would like to stress is that the fathers of quantum mechanics or fathers and mothers, because we also have Marie Curie and a few female scientists, but the fathers and mothers of these theories, from Heisenberg to Planck to Marie Curie to Einstein, etc., were not trying to develop new electronics or communication tools. They were trying to understand how the universe works. And it is this fundamental research that has then had a positive disruptive impact on society. And clearly, science gives us the knowledge and the tools also to address societal and planetary challenges. There is no way we can address those challenges without the help of science. Not only science, but also media, governments, policy, media, etc., but science is an essential component. As I mentioned, science nowadays is a driver of innovation because the goals of fundamental research in all fields, not just in particle physics, are so ambitious that really science drives the development of many new technologies. Science is also an example of collaboration across border disciplines and sectors. So today's challenges are global, this has been shown by the pandemic, but also interconnected. Climate change has an impact on malnutrition and poverty, and of course health also has a connection with difficult life condition, etc. So these challenges, because they are global and interconnected, they require collaboration between countries, so across borders, between different disciplines, as also shown by COVID, and between sectors, from research to private industry, policymakers, even the media. And so we need a holistic approach. And science is by itself intrinsically universal because it's based on objective facts and not on opinions. The law of nature are the same in China, in Switzerland, in the US, and unifying because the thirst and the wish to understand how things work at all level is a common aspiration of all human beings. So science can play a key role in connecting people in our fractured world and promoting collaboration. And this is my last slide. Training and education. Scientific training and education are absolutely fundamental. Today, STEM jobs, so jobs in science, technology, engineering, and mathematics, grow 3 times faster than any other job type. And yet, at least in Europe, only 20% of the high school students decide to pursue STEM studies at higher level university, etc. So we are not really preparing tomorrow's workforce. So scientific training is fundamental. But also in general, a general scientific education is crucial to forming well-rounded citizens, whatever they do in life, even if they are lawyer, economists, etc. And to give them, of course, tools like understanding what the scientific method is, evidence-based assessment, etc. And this is also important to increase trust in science, and we have seen this very clearly during the COVID pandemic. And last but not least, open science and scientific education accessible to everybody free of charge is absolutely crucial to reducing inequalities. Unfortunately, every time we have a crisis, the gap between the rich and the poor increases, between those with and those without access to education and technology, those who have the opportunity to travel and those that cannot travel. So this gap increases, but also even more than that, the fast evolution of technology increases this gap, because of course it leaves behind the people who do not have the access to the digital world. We know that in a few decades from now, most of nowadays job will be replaced by machines and automation, and of course the low-skilled job will disappear first. So we have to revert this trend, and so we have to build capacity through scientific training and education accessible to all. We have to build capacity by implanting scientific facility and tools in developing countries and providing the locals with the skill to operate and improve them, and we have to pursue open science. Science and education are empowering tools, and therefore they must be made available to everybody. So I'm going to conclusion. Sorry, maybe if it took a little bit longer than foreseen. Clearly, the COVID-19 crisis has shaken the world and shown that our societal system is not sustainable, and the old normal is simply not an option. So we need to adopt a values-first approach and strive for a world where there is a strong long-term commitment to knowledge and education for all. I mean, by governments, by people who have the power, where the well-being of humanity and the preservation of the planet are center stage, are really the primary goals, where collaboration, solidarity, and inclusion override competition, rivalry, and divides, and where a shared long-term vision wins out over individual or national short-term gain. And we think with these values, hope and trust can supplant fear and despair. I think these are values at the foundation of science, and so the world maybe should also listen to science, and promoting them is also a task of responsible science. And with that, I thank you very much, and over to the Q&A session.
Thank you, Dr. Janotti, for a fantastic talk, very inspiring and also very thought-provoking. So we will now have Dr. Renabel Reyes, the Philippines, in conversation with Dr. Janotti. Let me briefly introduce Dr. Reyes. She's an associate professor at the National Institute of Physics in the University of the Philippines. She heads the Data and Computation Research Group, which focuses on data-driven astronomy and computation in the Philippines. The cosmic during her PhD studies in the United States. So over to both of you. We look forward to hearing your conversation.
Thank you, Shobhana. And thank you again, Dr. Janotti, for the passionate and inspiring talk. I'm happy to have this opportunity to share the conversation with you and ask you some follow-up questions, and also maybe take some questions from the audience that come in. First, I think it was a great reminder that you shared with us that already at the core of CERN's founding convention are the values that we value basic research, open science, education, and international cooperation. And you showed that since then this has spread from Europe to the rest of the world, including many developing countries and many countries from where we come from and the audience. In fact, I'm happy to share that my own university in the Philippines just became an associate member of the Atlas collaboration earlier this year, and it has really brought great excitement to the physics community. And we look forward to having our colleague back and growing the research group here in Manila. Now, my colleagues and I also who engage in basic research in, let's say, particle physics, astrophysics, and general relativity often get asked about the relevance of our research to development and to the daily lives of our countrymen, and development, which is the theme of this conference session. Earlier in the panel session, Hannah also mentioned there's this concept of basic research as being a luxury only for developed countries, right, or more advanced countries. And for us also, this is usually phrased as something like, why spend money on basic research when so many people are going hungry, right, in the streets? And maybe this is asked also in in the advanced countries, but for developing countries, this has always come up. And sometimes it's asked as a sincere question, right? As for people who are maybe not as well versed in science and technology as we are. So would like to ask, as a physicist and as a leader in science, how do you think we should address this question? Or perhaps even, what do we need to do so that in the future, this question may not even need to be asked?
Yeah, thank you very much, Rana. I think thank you very much to the people who have asked this question. It's a really, really very good question. And of course, we understand, of course, it's obvious that there are very, very pressing and urgent problems across the world. And so, of course, one would be tempted to say, well, it's a luxury to invest money in fundamental research. On the other hand, based also on what I have shown, fundamental research is really one of the pillars for the development of society. Through nowadays in two different ways. One is the direct way. So we have discovered the Higgs boson. Sometimes people tell us, well, okay, but the Higgs boson itself, will it be useful for society? I cannot tell you today if the Higgs boson will be useful, in what the Higgs boson will be useful for society, but I think it will one day. Like when Mr. Thomson discovered the electron, at the time was just pure research, fundamental research. Today, without electricity, we could not live, not only in a developed country, but also in developing countries. So it's at the end, the impact of what we do extend across the whole planet. But also the second impact is the indirect impact. The fact that nowadays fundamental research requires really to push the technologies, and some of these technologies, of course, have a huge impact on health, for instance. For instance, at the moment, CERN is collaborating with a project to build inexpensive accelerator for cancer treatment using X-rays in Africa. So to build instruments that do not need super maintenance, are simple, robust, etc. So these things, of course, go to the advantage of everybody, and maybe they will not be there without the push coming from fundamental research.
That's great. Yeah, I think what you shared is just making concrete that basic research or science does not happen in silos. It's actually part of the whole scientific endeavor and technological endeavor and progress and development. All feed into one another and actually goes both ways.
Exactly, and belongs to everybody. So you also ask, how can we maybe reach out to people who ask this question? I think we scientists need to communicate more and better. Better means by making science more accessible in an easy way. Sometimes physics is considered to be absolutely, really something that cannot be accessed by the lay person, but actually it's not. It can be explained in a very simple way, but also in showing why science and knowledge are important for humanity, and not just for the developed country, but also for the developing country. And of course, as I said, I guess the people who are in those developing countries, which are suffering mostly nowadays, have also to see that what we do is available to everyone. So that's why CERN is we are promoting open science and education available to everyone and free of charge, not just for the rich, but to everyone.
Really benefits
yes, for everybody. Yeah.
Now, since we have here a lot of women scientists in the audience, I also want to touch on that aspect. And we've seen from your talk that CERN is truly an inspiring example and testament to what can be achieved by scientists working together with industry and educators towards a common goal. And that is only possible with great leadership. After 62 years, if I did the math right, of existence, you became the first woman Director General of CERN in 2016, and also the first Director General to be appointed to a full second term. So I'm curious, was this something that you envisioned in your career, especially when you were starting, or maybe as it was coming closer, was this something that you anticipated? And what did it mean to you when you were first appointed? And maybe now with some hindsight, what does it mean to you now?
Thank you. So no, it's not something that I was envisaging. It was not something that I had expected. And even, I must say, it's not something that I wanted all the time, because I like to do research with my own hands, and this is the thing that really gives me the greatest satisfaction and pleasure. So my soul is the soul of a researcher. So when I was solicited for this job, and for this appointment, there are search committees, there are interviews, etc., several levels of interviews, etc. I was very reluctant to accept and go and be a candidate to this job, because I thought that it will be mainly a job of administration and not really very far away from research. Then at some point you cannot say no when of course also the colleagues and the community pushes you, so I accepted to run, and then I was appointed. So in retrospect today, I must say that I was wrong in that, yes, of course, when you are the director of a big laboratory, you also have some administration work to do. But this is normal also when you get to a more senior position. When I was young, I could focus on my research because there were more senior people that really took care of the administration, of making the environment welcoming and buying things and setting up the lab in such a way that I could do my research in the best possible way. So it's also my duty to return that to the younger generation. But also because my current job is also very interesting and very exciting. Of course, I cannot do research with my own hands, but I still do a lot of science in terms of strategic planning for science, in solving sometimes problems, etc. But also there is this important component of collaboration, of having the possibility also of talking to many people, visiting many countries, even developing countries. And so that's, from the human point of view, is very enriching. And so I must say, it's a great job.
Wonderful. Thank you for sharing that. I think that many of us can relate, and that we should also see our careers as growing and evolving.
Yeah, exactly. Yeah.
And the opportunities are still, some maybe what we cannot imagine now. It's very inspiring. Now we can touch on the statistics that you shared also about percentage of women in CERN, women scientists, and women in senior positions have significantly increased in the past decades. As you shown, it is great to see that trend. But as you also said, that's not yet satisfactory where we are now. So my question is, are you optimistic that this percentage will come to reflect the general population, let's say 50-50? And how fast could that come? And also, maybe, how do you imagine CERN as a place with as many women as men, like in that future, hopefully not so far future? What ways do you think, and you could speculate here, maybe, what do you think will be different from how it is today?
Yeah. So concerning the first question, of course, there's been a lot of progress. Nowadays, in general, the fraction of women in science, in general, not talking about CERN specifically, is 20-30%, depending on the field. So clearly, there has been progress, because until 20 years ago, it was, of course, at the level of less than 10%. So, but we have to do more, and this means we have to do more at different level by attracting more girls to science, and this requires also cultural change for parents, for teachers. Too often I still hear young girls saying that they would like to become a scientist, but sometimes they hear that this is not a job for women. So that's we have to change culture and to attract more women, also by showing to them that something that I said in my presentation, science, it's absolutely necessary, a necessary component of, if we want to address the current societal challenges and planetary challenges, so climate change, environment, energy problem, etc. And so if they want to get engaged into this and give their contribution, that's studying STEM is a way to do so. How much time it will take, I don't know, but I now see a lot of progress also, a lot of push by governments toward gender equality, inclusiveness, equal opportunities, monitoring the careers, etc. I think that I am positive. I'm optimistic also because I'm generally optimistic that maybe the slope and the pace will accelerate in the future. And at CERN with 50% of women, well, CERN is already a diverse place, you know, but where diversity is not just gender diversity, it is diversity in terms of, you know, people, passport, languages, etc. So it's really a fantastic place, and I invite all of you to come and visit. If you walk at CERN, you see people from all over the world, and of course, research is nurtured by different ideas, different perspectives, different views. So diversity is a must for the success of science and research. And so I look forward to the time where CERN will be 50-50 women and men.
Wonderful. Just as a follow-up, I actually have a question from the audience. Well, we're here. Sorry, let me just find it. On the question of women applying to CERN, have you observed an increased number of applications by women willing to work in CERN? And could you share your observations during the pandemic, considering the number of new women at CERN? This is from Ariadna Garza Ortiz.
Yes, so the fraction of women applying for position at CERN has increased, although not at the pace I would like to see. And so that's why it's very important to increase the talent pipeline. So to have more and more girls and women that want to undertake a professional activity in science. The pandemic was actually a time where essentially, at CERN at least, we had most of our community in telework, so working remotely from home, etc. So, from this point of view, essentially, men and women were at the same level. Okay, so that was, and as a result of the pandemic, I think I mentioned this in passing. We have decided to increase also our telework flexibility to allow people to telework up to 40% of their time. And this, of course, will be also very useful for women. But there is a huge number of initiatives that we have put in place and that I've tried to summarize in one slide. And of course, they are not enough. We have always to do more and better. But I think that we observe, for instance, now, after several years of monitoring, that the progression of the careers is the same, that there is no salary gap at CERN for the same amount of jobs. So these things are now, there is improvement.
And there's gives us signs for hope for the future. Yeah, great. Thanks, and thanks for that question. We'll bring in another comment from the audience. This one is from Gabriela Ferreira from Brazil. She says, I would like to thank you for the excellent presentation and for your dedication to representing women in such an important position as Director General of CERN. I had the opportunity to participate in the teacher training program in 2013, visiting detectors and accelerators. So she's now an assistant professor at the Federal University of Santa Catarina in Brazil. She says, but one of the most important things for my training was meeting and talking with researchers involved in the experiments and building a more renewed image of what science is and how science is done as a collective and interdisciplinary enterprise. So in this sense, if it's possible, I would like you to comment about CERN's role in the scientific dissemination to the general public.
Yes, thank you very much, Gabriela, for your comment. And of course, you know CERN from inside, having been a participant to our teacher program. Yes, indeed. One of the important things that we do at CERN is to disseminate science through our scientists. So, for instance, we have, before COVID, now with COVID is a strange situation, but before COVID, until 2019, we will have more than 150,000 visitors to CERN facilities a year. And actually, most of these visitors come from far away. More than 60% of them come from more than 800 kilometers. So it's not just a local tourism. And more than 50% of them are high school students. So a lot of visitors. And what is very successful with them is that the guides are the scientists themselves. So engineers, technicians, physicists, etc. Because, as Gabriela says correctly, the public want to see the scientists, wants to talk to them, wants to understand from us why we are doing this job, etc. And actually, sometimes they come with some prejudices about scientists. They think that we are crazy people with our hair going all over the places, etc. But actually, we are normal people. So they're not disappointed. I think they are very happy. So now to expand our opportunity to offer of scientific dissemination, because I mentioned that we had under 50,000 visitors, but actually we received annually 300,000 requests for visits, and we could not accommodate all of them and satisfy all of them. We are now building a new learning center, which is called the Science Gateway, where we will have also laboratories for hands-on activities for kids, in particular for girls, starting at the age of 5. So the kids will come starting at age 5, and we have 3 different bands, 5, 8, 8, 12, 12, 15, and they will do their own experiments with their hands. So they will really experience what being a scientist means, having a problem to solve, asking a question and trying to find a solution, building the instruments to find a solution. So I hope that will also give another boost to our capability of disseminating science to the public, and thanks to Gabriela for the very nice question.
That's exciting. Okay, we'll end with this last question. So I was going through some of your other interviews, and I read that reading a biography of Marie Curie inspired you to go into science yourself. And now many young women have been inspired by your life and your life's work, go into science as well, and all that you're doing with CERN will have impact for many more generations. So what, with this group of women scientists like me and in the audience, what would be your message or advice for us, especially those of us just starting early in our careers?
So I will say that, first of all, a few things. First of all, that for me, there is nothing more rewarding than contributing in our corner with our humble work every day in contributing to increasing the knowledge of humanity, whatever the field in science, from physics to, to biology, etc. To really being able to be part of this long path of knowledge that humanity has started many thousands of years ago, and so being able to continue in this along this path. And first thing. Second, I would also like to tell that, of course, life is full of, present us with challenges in our private life, in our professional life, and of course, sometimes that research is not an easy job because it requires really working at the frontier of knowledge, and so it requires a lot of courage, a lot of motivation, a lot of determination, a lot of passion. So, and I invite everyone to be really stubborn in our goals, to go out, another objective to move ahead, not stubborn in the sense of not being flexible, but being really convinced in going ahead. So this is very, very important. And last but not least, humility. Newton used to say, what we know is a droplet, what we don't know is an ocean. So I think we have to be very humble to recognize that we are little human beings in a big universe. We know already a lot, we have made a lot of progress, but there's still a lot to know. And the best way to learn and to do more is to be humble.
Oh, love it. Be stubborn and be humble. Thank you so much again, Dr. Gianotti, for this time with us.
Thank you very much for the very good questions and invitation. Thanks a lot. Thank you, Marian.
We bring it back to Shobhana to close the session.
Thank you so much, Dr. Janotti and Reina, for a very interesting discussion. Thank you, Dr. Janotti, for sparing time from your very packed schedule to spend some time with us. That was really a very interesting talk and interesting discussion. So let's now go back to the panel discussion, and maybe we can have our panelists back. So can we have Maryse, Marian, Kate, and Hannah back if they're available? Hello, Kate. Welcome back.
Hi there.
And while we're waiting for the other people to join us, I wanted to ask you both one thing. I mean, this is not exactly related to sustainable development, but I wondered what you both thought about this. We've talked a lot about how basic science is important because it can be useful and it shouldn't just be restricted to the developed countries. But what about just the joy of doing science and the intellectual pleasure that one gets from doing basic science? Should that be restricted only to a small group of people? I wondered what you all thought about something like that. And what about something like, you know, what might be called a vanity project, like having a manned mission to the moon? I use the word manned in quotation marks because, for example, India is thinking about doing that, having manned missions to the moon. And is that what a developing country should be focusing on or not? I mean, these are your personal opinions. I'd like to know what you think. Maybe Reina first?
Yes, no, definitely should not be restricted to a small group of people. And as Dr. Janati said, no, this is something that is open to all humankind, and that's something that we like to participate in, just like creating art or poetry or beautiful things. Our scientific discoveries and theories are also beautiful things that we create as humans, as creative beings. So definitely my colleagues who do fundamental physics research actually emphasize this and stake their life on it. For me, actually, it's more. I found that I can try to do both. So in my career, I started with more basic science, astrophysics, but then found that the data analysis can be applied to more practical applications. So now I also do data science consulting, which is more on the practice side. But there's really a continuum, right? You cannot, as I think was brought up earlier, these do not happen in silos. Maybe some researchers just focus on one part, but they're not separated from everyone else in the research community, and not just in their own country, but globally. So yes to science for curiosity and pleasure as well.
Kate, what do you have to say on this topic?
Yeah, well, of course, I totally agree with Reina. We all do science fundamentally because we enjoy it, right? And one of the things I really enjoy about working with people from all over the world is that shared passion for a similar topic. And I think it's really great how that is a great force for bringing people together and encouraging collaboration. And I also think it's an important point to remind ourselves, because when we're talking about encouraging people to become scientists and the importance of science for sustainable development, often we're talking about it as how that how scientists can contribute to the economy and contribute to societal needs. And we forget the fact that actually it's also some sort of human right to be able to have access to science and be able to study it if that is your passion. So I think it's a really good thing to remind ourselves of, that people should have access to science also because it's their passion and they want to have access to it. Yeah, and you also asked about going, traveling out to the moon and these sort of things. So that's a really complicated question. I'm not sure if I've got a very good answer, because I think in some ways when you're doing that kind of science, just as any kind of blue sky kind of science, things will, you get education out of those projects, and you'll get outcomes that maybe you didn't envision. However, every country has to make their priorities of what they want to invest in. And obviously expensive science, most countries probably want to focus on one or two. But I think it's fantastic that India is sending somebody to the moon in general, because I think it's a wonderful tool to inspire young people.
So, Marian, we're talking about just the joy of doing science, and that is also important, and one should decide what kind of science one does, not just because it is useful or may be useful one day, but also because of the intellectual pleasure one gets from it. And that should be the right of people everywhere to pursue, not just in developed countries. So I'm guessing that you would agree with that. Do you have something to say? And we'd also be interested to know what made you choose the field of research that you went into.
Yeah, absolutely. People should be able to do what inspires them and what drives them, and not necessarily what looks fancy. I'll use the word again. But so I'm a chemist because I have always been curious about the things around me growing up as a girl on a school compound, which was full of woods and then greenery. So I spent a lot of my time outdoors, and I had questions for every new thing I found for my parents, and they had to answer every one of them. So it was just natural that I would do science as a course in the university, and then went into environmental chemistry because it's more or less encompasses all the aspects of chemistry, a bit of each one of them. I didn't want to limit myself to only one area of chemistry. So I enjoy what I do together with public engagement like we are doing. And it's always a joy to be part of this.
And since we are all women in science, I'm just curious about whether any of you felt that the field you wanted to go into was traditionally a male field, and that made you hesitate, or that was not an issue at all for you?
Can I start?
Yeah, sure.
Yes, I never was conscious about gender until I think I started my studies in the university because I grew up in a home where we were never told you cannot do this or you can do that because you're male or female. We grew up, we were allowed to do the same things. And I also went to an all-girls secondary school, so I didn't have to be, we were not mixed up with boys for that conversation to happen. So it was in the university that I realized that, oh, okay, so being a woman or a girl was different or is different, and you are perceived differently by the rest of the world, so to speak. So personally, it has never been an issue for me, though I realized that we were just about 22 of us in a class of a little over 100, only 22 females at the time in our first year. I personally didn't have a problem at all being among the minority.
So that's, I mean, it's interesting that you make this point about being in a all-girls school, because that was true for me as well. I went to an all-girls school, and we were never told that you shouldn't do something because you're female. And it was quite a shock to me to then go to a co-ed college and find that certain things were expected of men and certain different things of women. I actually I was in a class of 75 where there were only 4 women. And there were some expectations that the women wouldn't do better academically than the men, etc. So what about you, Reina? Did you feel that you were going into a male preserve when you chose to go into physics and gravitation?
Actually, similar. I think, coming to a university, there were about 10 women out of 80 physics.
Did you also go to an all-girls school?
In my high school, I actually went to a co-ed high school. That's a magnet school for scientists. It's called the Philippine Science High School. So in that sense, I was lucky. That we were all encouraged to become scientists, and there were also more men, but but it was closer to half, and I think even closer now. But actually, I think I would also resonate that it didn't bother me so much, especially since, and maybe you were just too humble to say it, but we were doing better than many of our male colleagues anyway, and maybe that's also something that helped us, push forward. That didn't become an issue for us even then.
And Kate?
Yeah, I think I have slightly similar to bits of what everybody else said. I know, I never felt it was something that was odd for me to do, especially when you're younger, because, you're reading books and you're learning about stuff and you feel complete access to it. And I think it's only when you get older and you start taking courses where you feel in the minority that suddenly, sometimes you feel a little bit excluded. And I found when I was, young, doing my PhD at CERN, sometimes I'd be in groups of 20, 30 people and be the only female, and it's just that feeling of feeling different, or feeling a bit like your voice is different to everybody else's, and you can just feel that you're a different person in the room. And especially when you're a bit of a shy or introverted person, that can give you a bit of pressure. So as things are changing and things are it's evening up, I think that's really helpful, because then you don't feel like the odd one out, and you can that pressure's taken it off.
So there's a question from Zebe Bienus Nuru for Marian. I apologize if I'm pronouncing people's names incorrectly. It says, Marian, you mentioned that you are engaged with the public while working on chemistry-based research. Can you mention in what way you are engaged with the public?
Yes, so I think scientists typically shy away from the press. I don't. So every time I am invited to share my opinion on a subject of interest or out of my research, I'm very much open to that discussion. I have done this nationally and internationally as well.
I think she also had a question. It was for Fabiola Gianotti about CERN, but maybe we can discuss it anyway. It was about whether there are specific supportive systems in place for women. For example, how are women accommodated who spend some time off from their career for taking care of small kids? Maybe you can all tell us about what you're aware of in your countries or your institutions. Are there any mechanisms in place? Reina?
Right. This is, I would say, actually, there's no specific support system and maybe this is um, part of the gap. Um, um, and yeah, I would say that there's only in our senior faculty in our institute, there are only 4 out of 20 professors that are women, and I'm the youngest one that just joined, who just joined. So this is also something that I am yeah, that's in my mind, and maybe what we can do for the next generation of women physicists as well, and scientists in general.
Maryse, welcome back to our panel. We're discussing whether there are any mechanisms in place for women who have taken a break to have children to bring them back into academia or research, back to their jobs. Are you aware of anything like that in your institution or your country? You're muted. You have to unmute yourself.
Yeah, sorry. In our institution, there is no system like that, unfortunately. And but I think it depends of the in area. In letter, people from law and letter, I saw some of women doing. They have like a child care support by themselves, so they organize in order to have it at the university. But from us in science, in like they say pure science, there is nothing because first there are no women. For example, in our department, I'm the only female physicist. So it's something for them. It's new. It's not new, but it's not mandatory because there is nothing in this kind. But since like 1 month, because our ministry, she's a female, so I really emphasize her to put it in place. So now we are doing policy maker in order to have those kind of structure in place for women to be able to have this kind of childcare. So I hope in the next 6 months it will be able to establish it. So because it was not existing before.
Okay, so we have strayed away a little bit from the topic of our panel discussion, but I think this is still something of great interest to all of us. So maybe we can stay with it for a couple of more minutes. So I do want to mention that in India, they have realized that the main reason why there's so few women in science is because we lose women after they get married and have children. And so the government has specific programs to bring back to the scientific mainstream women who've had a break in career. There are fellowships specifically for women who've had a break in career. And this is something that maybe other countries could also think about. And I've also done an analysis of data of participation of women in science across countries, like looking at what percentage of, say, bachelor students studying science are women in a country versus what percentage of scientists working in the country are women. And if you look at developed countries, then for the most part, both those numbers are sort of the same. So if they have a low percentage of women in science, they're losing them at a much earlier stage, maybe already at the high school stage or whatever. Whereas in developing countries, the percentage of women studying science is typically quite high up to the bachelor's level, sometimes even up to the PhD level. And after that is when it drops. So the situation is quite different in developing countries. We are really losing women after they have studied science because of family responsibilities and societal pressures. And so we need to think of different solutions for specifically tailored for this cultural and societal situation in developing countries rather than just copying blindly the solutions that people have come up with in the developed countries. So I just wanted to make that point. There is a comment from Shalini Abesinghe. She says, on my point of view, I believe that there's limited access for students to do science for intellectual pleasure in developing country rather than doing it for a career purpose. Hence, I believe it's important that you can come up with a foundation or something that financially and intellectually supports to overcome that limitation. Would you agree with her? Do you think that if you're in a developing country, you don't have the luxury of doing basic science just for intellectual pleasure?
Yes. Can I?
Sure.
Yes, I think the general perception of parents and families is that their children should pursue a career which have a short turnaround time. So, for example, pharmacy, medicine, and then right afterwards, the government employs you and then you are paid. But when you go the trajectory of basic science, you look into maybe a PhD, that is a long haul, and afterwards you have a lifetime of career. And so, especially for females, a lot of families will advise or have advised, and I have encountered it a lot of times when I'm counseling youngsters who want to enter the university, that they want them to do maximum 6 years program and then settle down and live life, so to speak, than to go on a long journey of scientific inquiry, which might never end or might never reach a point of discovery.
Yeah,
so it takes a lot of interest and passion and determination actually to do this in a developing country.
Yes, certainly that's true in India. I mean, parents want their children to become engineers or doctors. And if they do science, they want them to get a job straight after their master's or something and not do PhD. And then after PhD doesn't end because you have to do a postdoc and you're maybe 35 or even 40 before you get a permanent job. And that seems very shocking to them. Maryse, do you have anything to say about this?
No, case in Congo, like Marian said, it's if you would like to succeed, if you would like to have a good life, you need to follow those paths. Don't follow what you would like to do, but follow something you will find easily a job. So it's the same. It's the same case back home in Congo also, unfortunately. But I think since 1 or 2 years.
Yeah, go ahead.
Hello?
Yeah, go ahead.
The last 2 years, I'm seeing some change. I'm seeing some a generation of women. They are really they are trying to be confident on their passion. They are really passionate about what they are doing, even though it's like basic science. So I can see that on younger than me for sure, younger students, they would like to do that. They would like to do pure mathematics like Jana. They would like to do, and it has changed a little bit since 2 years. So I think hopefully it will continue to change, let's say.
But do you think in general, this is a question for all of you, that the sort of the problem in the quotation marks of women in science, the underrepresentation of women is more of a problem in basic science than in applied fields of science?
Absolutely. Yes. When you come to my university and you go to the departments that are applied, the percentage is about 50-50 male to female ratio. But when you come to the physical sciences or basic sciences, it's always a very small fraction. So yes, there's the desire to.
Do you have any idea why that is?
It's about the same issue I raised earlier, that their sponsors would want them to pursue a field of study or a discipline which has an already made job for them.
But
Because some of the
why is that more so for women than for men?
because the general perception is that women are weak, soft, and so don't have to struggle too much in life. So go for that which is safe. Go to the safe place where your job security is assured in the next 4 to 6 years than go on the long haul of 7, 9 years PhD and then postdoc and the rest of it. Yeah.
So we have a
So
comment.
that's the perception. Yeah.
We have a comment from Tushari Sugandhika Suresh. She says there's so many programs for early career females, but very few once you're over 45 years of age. I suggest that some programs are started to support older scientists who need to get trained in laboratories or institutions. Any thoughts about this?
Yeah, I'd like to make a comment
Yeah, sure.
actually, because I absolutely agree. This is a really big problem. I work with a lot of scientists who are exactly over 45 years of age, or even just over 40, and that cuts them out of eligibility for a lot of training. Some people, especially, I think sometimes more women, because maybe during when they're younger and they have children, they may not be able to do their masters or PhD till later, and unfortunately, there's very many opportunities that they're not allowed to apply to, or they'll be cut out of because of the age. And really, that is ageism, which is fundamentally should be illegal under our human rights, and yet it's still there in the scientific community. And I think that's something that hasn't been addressed, and that is something that we definitely need to start talking about and solving. Otherwise, again, this is something that will over proportionally affect women if you take time out to have children, if you want to do extra training and opportunities.
I can see everybody nodding. Does anybody else want to say anything on this point? Reena?
No, yes, it's also true for the awards, where we
Yes.
have age limits where we suddenly exclude everyone else who may have needed more time, as Kate said. And yeah, it's a good, good to provoke that discussion. And I think,
do you think there should be no age
sure.
limits, or do you think there should be different age limits for men and women, or what would you suggest?
Maybe I can just say, yeah, I think it should be a matter of what level you are, not age. So, I mean, I just think having age involved is rude in any way. If it's for an award or it's for training, it should be to do with your level. So anyone with a MSc should be able to apply for a PhD. And if it's for award or in a fellowship, it should be dependent on your stage in your career.
So there's another comment from Doris Berko. I think this is about when we were talking about the pressure from parents to go into certain fields. She says this is very true in Ghana. Most high school students I have encountered mention medicine or pharmacy or nursing as their preferred choice, and it's not really their fault. It's the system that we grew up in. We have just a couple of minutes left. Any last thoughts that you want to share before we wrap up? Marian?
Yes, I would like to reiterate that the dedication of next year to basic sciences is very important, cannot be overemphasized. And I believe all scientific organizations around the world are going to rally around this theme and publicize basic science to the last citizen of the world, so that collectively we'll champion the cause of what drives every research in the world. And thank you to OWSD and the organizers for inviting me to be part of this discussion. Thank you.
Thank you so much, Marian. That's beautifully put. Maurice, do you want to say anything? Any last words for us?
Yeah, I will say that even there is no, like, you need to choose what you would like to do. It could be basic science or apply, but the most important part is to do something with passion. If you are passionate about it, whenever place you could be in Europe or in Africa or whatever place, people will always be there to encourage you. People will always be there to trust on what you would like to do. It could be basic science or whatever. For my case, it was the early career fellowship, which has really opened the door to many things. Because when I decided to come back home, I didn't have any equipment. I didn't have anything. So, but I was telling that I would like to write this project, and yeah, they trust me. They trust my idea, even though I was very far in Congo, and I'm a mother, and I was able to because when you have the early career fellowship, there is a small part for child care, for example. So it takes into account of this thing. So there are always people to believe on whatever you would like to choose. It could be basic science, it could be applied science, and yeah, to follow your passion, to be persistent, and to be really passionate about what you would like to do. That's what I would like to add for sure.
Thank you so much. Very true words. Reina?
Yes, just to say, it's been a really enriching and inspiring discussion, inspired by the panelists here and our speaker. And thank you to OWSD and everyone behind this. Also looking forward to next year's International Year of Basic Science, and maybe this will can be our anchor to spread this discussion and even debate, no? Because maybe this is really what our countries and our societies need to grapple with, since this hasn't been, I mean, there's no set answers yet, and we want actually for different ideas and opinions to come out, and also maybe then increase the understanding across different communities, scientists, citizens, and government. So glad to be part of this conversation, and I think this discussions have also just proved or shown even more how connected and how common we are actually, even from different parts of the world. So
thank you so much. And Kate, any quick last thoughts?
Hi, I think everyone's summarised everything really nicely. It's just been a real pleasure to talk with everybody today, and thanks so much to OWSD for organising this conference. It's really been inspirational, and yeah, next year with this International Year for Basic Science for International Sustainable Development. Yeah, I just think this is a really good opportunity for us to have more discussions like this and put pressure on our government's policymakers and funders to start, really solving some of the issues we have to support scientists and women scientists more. Thank you so much, Shobhana, and thanks to everybody for the discussion today.
Thank you, everybody, so much for a really interesting, thought-provoking panel discussion. Thank you to OWSD for organizing this and for inviting me to moderate this discussion. I would encourage everybody in the audience to maybe continue this discussion in their home institutions, in their countries, to widely promote that next year will be the International Year of Basic Science for Sustainable Development, and continue this discussion. And as Kate mentioned, lobby to promote the related issues. So that's it for today. Tomorrow's session will be on the applied sciences and their impact on development. The keynote speaker will be the renowned agrarian economist from India, Beena Agarwal. And the session starts at 1400 Central European Time. See you all there, and thank you very much.
Yeah, hi everyone. Just to finish up with some housekeeping. Thank you all for such a wonderful session, and thank you to Shobhana for moderating. Thank you to Rainer for interviewing. Thank you to Kate and Marian and Maryse and Hannah for being on the panel. Thank you to Fabiola Gianotti for the wonderful presentation. I think Shobhana's call out to everybody to start discussing basic sciences for development is an excellent call. And in fact, our national chapters would be very well placed to start having those kind of conversations. And tomorrow we're going to have, as Shobhana has just mentioned, we're going to have the applied sciences for development, which, as you know, is much more obvious to talk about how applied sciences are relevant to development. But it follows on really nicely from this discussion here today. And I think also those difficult distinctions between basic science and applied science that we can think about much more. So now everybody just left. Bye, everyone. Yeah, so straight after this, on Monday, we will have the poster session that follows up the basic sciences for development. So that's an opportunity for you, again, to go and talk to people who are standing by their posters, who have submitted a poster on their research in basic sciences and how it's relevant to development. You can go and visit their posters at any time. You can click on their posters and watch the videos. You just scroll down the menu on the left-hand side, as usual, where you find the little poster landscape, and you can go in there. But for the actual poster session, as I said, that's on Monday at 2 o'clock, 2 o'clock till 4 o'clock. So many of you, I think, yesterday did join the poster session, and those of you that managed to understand how it worked had a great time, and you managed to talk to people. We got some great feedback from people who said that they managed to connect with people from their countries or people in their disciplines and talk to them. Some others of you found it a bit more challenging. Some of you got lost. Some of you couldn't get your mics to work or your video camera to work. So perhaps practice going into the lounge and with your avatar and meeting people and turning your mic on or turning your video on and seeing if you can have a conversation, so that by the time Monday comes around, you'll understand better how to interact with people in the poster sessions. On Tuesday next week, we'll have the applied sciences poster session, and then Thursday we'll have the final poster session on the sex-gender ratios in research. So please do come back tomorrow at 2 o'clock when we have our keynote speaker, Bina Agarwal, who is an international agrarian economist, going to speak. She's going to be interviewed by Doreen Odongo, who's from Kenya and is the head of communications at the African Women in Agricultural Research and Development, otherwise known as AWARD, a very well-known and effective organization based in Nairobi. And then again, there'll be another panel session with three OWSD members from Kenya, Nepal, and India. So another great day lined up for you, and we're all really enjoying all of your contributions, and the members' questions are so fantastic, and it's great to see you all engaged. And yeah, if you want to make any comments about the conference in general, please do put them in the chats, and we'll try and follow up as well everything that you're asking us. So have a good morning, afternoon, evening, wherever you are, and see you all tomorrow. Bye.